differentiation, in that the successive differentiation. Now, what is meant by successive differentiation? Or it is also called as nth order derivative of some standard functions. So, successive differentiation is the process of differentiating the given function successively for n times, and the result of the such differentiation is called successive differentiation. Means first we find first derivative, then we find second order derivative, then go to third order derivative, then go to fourth order derivative, and so on. This process is called successive differentiation. So now there is no general formula to find the nth order derivative of the given function. Till the date we don't have any general formula so that we can generalize the we can find the nth order derivative of the given function by using the formula. No, it is not possible. So we have to use the algorithm to find the nth order derivative, to find the the method of mathematical induction wherever applicable. Now, how to find the successive differentiation or the nth order derivative of the given function? So step first, use simple differentiation to get first, second and third order derivative. पहिला, दुसरा, तिसरा आपण जे आतापर्यंत काढत आलो त्या पद्धतीने डेरिव्हेटिव्ह काढायचे. नंतर ऑब्झर्व द चेंज इन द कोएफिशियंट्स, द अँगल्स, द पॉवर ऑफ द फंक्शन अँड द साइन ऑफ ईच टर्म. त्या आलेल्या फर्स्ट ऑर्डर, सेकंड ऑर्डर आणि थर्ड ऑर्डर या डेरिव्हेटिव्ह जे आले त्यांच्या आपण सगळे कोएफिशियंट्स नीट पाहायचं, त्यांचे साइन्स पाहायचे, त्यांच्यातले अँगल्स, ट्रिग्नोमेट्रिक फंक्शन असेल तर त्यांचे अँगल्स पाहायचे आणि प्रत्येक टर्म ऑब्झर्व करायची आणि मग एक्सप्रेस द nth डेरिव्हेटिव्ह विथ द हेल्प ऑफ दिस पॅटर्न्स ऑफ चेंज दॅट यू ऑब्झर्व, and this will be the general formula for nth derivative of the given standard function. So let us study some of the solved examples on this nth order derivative. So we have to find the derivative, nth order derivative of the x raised to m. So what is y? Y is equal to x raised to m. So differentiate with respect to x, we get dy by dx is equal to d by dx of x raised to m, where m is equal to x raised to m minus 1. Now again differentiate with respect to x. What we get? Now here m is a constant, so we can take it outside. Derivative of x raised to m minus 1 is m minus 1 into x raised to m minus 2. Now similarly again we'll differentiate with respect to x. So we get d2y by dx square in of dy by dx is m into m minus 1 into d by dx of x raised to m minus 2. So its derivative is m minus 2 into x raised to m minus 3. This is the third order derivative. Now, so the general, how to generalize the nth order derivative? Okay, so here is the cube. So m minus 0, m minus 1, m minus 2. So here cube, so n minus 2, so 3 minus 1, and m minus 3 is 3. So dn by dx raised to n is m into m minus 1, m minus 2, and so on, m minus bracket n minus 1. So you have to less 1 from this nth order derivative and we will subtract it from m, and then x raised to m minus n. Then further we can simplify it, m minus n minus 1 we can go by deducting minus 1 minus 2 minus 3 minus 4 minus 5 minus n minus 1 minus n and so on. So by this way to get the factorial of the given function. Look at here, m minus n minus 1, then m minus n, m minus n plus 1, and so on up to 1. And these terms we are adjusted, so they must be cancelled. So m minus n and m minus n plus 1 and so on. 5, 4, 3, 2, 1. So now this is m factorial. Now what is m factorial? M factorial is the product of the numbers which are less than or equal to m. Similarly, m minus n factorial, and the term x raised to m minus n as it is. So this is the formula of n general nth derivative of the given function. Now if m and n are same, then if m and n are same, then x raised to n minus n is 0, so x raised to 0 is 1, so we got n factorial only. And if m is less than n, so degree of this polynomial is less than the order of the derivative, then its derivative will be 0. Derivative will be 0. Nth order derivative of 1 upon ax plus b. Y is equal to 1 upon ax plus b. So differentiate with respect to x. Its derivative is minus 1 upon ax plus b bracket square into d by dx of ax plus b. Derivative of ax is a and derivative of b is 0. So we get minus 1 into a upon ax plus b bracket square. Again differentiate with respect to x, d by dx of minus 1 times a into d by dx of 1 upon ax plus b bracket square. So we can take this denominator term to the numerator by ax plus b raised to minus 2. Then we will use the formula f of x raised to n is n times f of x raised to n minus 1 into f dash of x. So d2y by dx square is minus 1 square into 2 into 1 a square upon ax plus b bracket cube. Again differentiating with respect to x. So we get d cube y by dx cube as minus 1 square 2 into 1 into a square minus 3 upon ax plus b bracket raised to 4 into d by dx of ax plus b. Its derivative is a. So d cube y by dx cube is minus 1 square 3 into 2 into 1 into a cube upon x plus b bracket raised to 4. So if we look at this cube, then what is there? As here is the cube, so 3 into 2 into 1 is there. Again minus 1 square, so 3 minus 1 is there. Then a cube is there, a raised to n, and here 3 plus 1, that means 4 is there. So we can generalize this formula. dny by dx raised to n is minus 1 raised to minus 3. This is minus 1 square and this is minus 1, so minus 1, we got minus 1 dny by dx raised to n minus 1 raised to n minus 1, n minus 2, n minus 3, and so on to 1, then a raised to n ax plus b raised to n plus 1. This is the, or we can write this n into and so on, this factor as n factorial, because it is a product of all the numbers which are less than or equal to natural numbers less than or equal to n, so n factorial. This is the nth order derivative of the given function. Find the nth order derivative of log of x. So let y is equal to log of x. Differentiate with respect to x. Its derivative is 1 upon x. Again differentiating, we get minus 1 upon x square. Again differentiating, you get minus 2 upon x cube. So this minus 1 into minus 2. So what we get? Minus 1, minus 1, minus 1, minus 1 square. Then 1 and 2 as it is. Then x cube. So the general nth order derivative is given by minus 1 raised to n minus 1. 1 product of 1, 2, 3 and up to n minus 1 upon x raised to n. This product of all natural numbers which is less than or equal to n minus 1. So it is n minus 1 factorial. This is the nth order derivative of log of x. The next example is sine x. We have to find derivative of sine of x. Now differentiating with respect to x, d by dx of sine x derivative is cos x. Now if we goes on differentiating, alternatively we will get sine x, cos x, sine x. So we cannot generalize this formula. Okay. Now whenever we are getting the functions alternately, then we must think of some common function. So here this whatever cos x I am getting, I will convert it into the sine by using other angle formula. So cos x is sine 90 plus x. 90 sine 90 plus theta is cos theta. So I have converted this cos x into sine 90 plus x. Then I will differentiate this with respect to x. So I get sine of f of x is cos of f of x into f dash of x. But f dash of x is just 1. So what we get? Cos of 90 plus x. So again I will convert this cos into sine using sine of 90 plus theta. So we get sine 2 pi upon 2 plus x. That means 2 times pi by 2 plus x. So we will differentiate this function with respect to x. Sine of f of x is cos of f of x into f dash of x. Again we get cos of f of x, but I will convert this cos again into sine by sine pi by 2 plus theta. So sine 90 plus pi by 2 plus x. So we get 3 pi by 2 plus x. So we can generalize this to get the nth order derivative. D raised to ny by dx raised to n sine as it is third derivative. So 3 times pi by 2. Nth derivative. So n times pi by 2 plus x. So by this way you can find the nth order derivative of sine x. The nth order derivative of cos of ax plus b. Same. Derivative of cos will get sine. Then again sine derivative cos. Then again cos derivative sine. It will be continuously alternate. We get alternate derivatives as sine x and cos x. So here we have to again use the allied angle formula. So sine minus sine theta. I can write it as cos of 90 minus 90 plus theta is minus sine theta into d by dx of ax plus b. So we get the first derivative as a cos pi by 2 plus ax plus b. Again differentiating with respect to x. Now a is a constant, so derivative of cos theta, cos of f of x is minus sin f of x into f dash of x. But derivative of f dash of x means d by dx of pi by 2 plus ax plus b. Pi by 2 is constant, b is constant, a is constant. So we get only a. So again the first a and another a is a square, and I have converted this minus cos minus sine theta is into cos of 90 plus theta. So we get a cos 2 pi. Though we can cancel these two, but don't cancel it because we have to generalize the formula. It will help to generalize the formula. Again differentiating with respect to x, we get the third order derivative as the previous differentiation. D cube y by dx cube is a square cos of pi by 2 plus 2 pi by 2 plus ax plus b. So a cube cos of 3 pi by 2 plus ax plus b. So we can generalize from this formula. We can generalize the nth order derivative of cos ax plus b as a raised to n cos of n pi by 2 plus ax plus b is the derivative, nth order derivative of the given function. Now you have to find the nth order derivative of e raised to x sin bx plus c. Let y is equal to e raised to x sin bx plus c. So you have to differentiate this function with respect to x. So here we have to use the product rule. First function as it is derivative of the second plus second function as it is derivative of the first. So sin bx plus c its derivative is cos of bx plus c into d by dx of bx plus c. Sin bx plus c into e raised to ax into d by dx of ax. Now bx plus its derivative is only b because c is a constant, its derivative is 0, derivative of x is 1. Here is also derivative of x is 1, a is a constant, so its derivative is a. So e raised to ax in bracket b cos bx plus c plus a sin bx plus c is the first derivative of the given function. Now again what we will do, we will adjust this because I have to write this whole function in only one form. So here is b and here is a. So I will divide this term by root a square plus b square, by this root a square plus b square. Now b upon a root a square plus b square is sin alpha, and a upon root a square plus b square is cos alpha. We will take because they are constant, and with the help of these two terms I can find the value of alpha. Alpha is tan inverse of b by a, that is tan alpha is sin alpha upon cos alpha, and then alpha is tan inverse of b by a. So after putting these values we get sin a cos b plus cos a sin b. So by using that term here you get a sin of a plus b, so sin bx plus c plus alpha, and a square plus b square, square root means a square plus b square is to 1 by 2. Now again we will differentiate this function with respect to x. Now root this a square plus b square raised to half is a constant, so we can take outside, and then we have to find the derivative of only e raised to x sine bx plus c plus alpha. Okay, so using the product rule, first function as it is, derivative of the second function, plus second function as it is, derivative of the first function. So continue. D2y by dx square is a raised a square plus b square raised to half e raised to x cos bx plus c plus alpha into d by dx of bx plus c plus alpha sin bx plus c plus alpha e raised to x into d by dx of ax. Now we will take e raised to x common because it is present at each term. Then again I will make the same arrangement, multiply divided by root a square plus b square. Then this is our sin alpha, this is our cos alpha, and tan alpha is b by a. Tan alpha is b by a, so alpha is tan inverse of b by a. So again I get sin a cos b plus cos a sin b, that is sin bx plus c plus alpha is 2 alpha. So and 1 a square plus b square raised to 1 upon 2. So we get 2, 1 plus 1 is 2 upon 2. So this is our second order derivative. Now on the same line we can find the third order derivative, e raised to ax a square plus b square raised to 3 by 2 sin bx plus c plus 3 alpha, where alpha is tan inverse of b by a. So we can generalize this term and we will get the nth order derivative as dn by dx raised to n is e raised to ax a square plus b square raised to n by 2 sin bx plus c plus n alpha, where alpha is tan inverse of b by a. So these are all solved examples on the successive differentiation to find the nth order derivative of the given function. We will now we will go to our last exercise 1.5 from the same chapter, differentiation.